should say. There we go. No, that's a slight delay. Oh, your screen is already up, actually. Good. Well, hello, everyone. This is Brendan Hall here from the Software Underground. And today we're really pleased to have Dewey Dunnington, who's going to give us a tutorial on how R can be used for geocomputing. So this is going to be an exciting presentation. I think, you know, different languages really excel at different things. And even though, you know, I've been using Python for a long time, when I first took a look at R, it really helped me understand what data frames are all about and really why these languages excel at data science, and how R kind of broke a lot of ground for that Python and Pandas, you know, really tried to imitate. So, you know, there's a lot of great utilities in R, and you know, it's very useful for geoscientists. And I'm looking forward for Dewey's presentation today. So with that, Dewey, please take it away.
Yeah, thank you so much, Brendan, and thank you for getting all of this set up, because that's the hard part. Just the talking about R for 2 hours is something that I love doing, and so it's an easy thing for me to do.
I think your video might be frozen. You might try and
exit and reshare. Was that
just click your video in the meeting, your video off and on again.
Okay, there we go. We're off and we're on. Is it still frozen, or?
Yeah, I'll let you know in a second. There's a slight delay on the. There we go. You're
sure, no problem. So I'm gonna just talk over this loop for just a second for those tuning in. So you've got a URL that you can go to, and I'll demo how to do this in a second. But basically, I have set up an RStudio Cloud project so that you can just click on it, and you'll have to register for an account. You can click, if you're using GitHub, you can say login through GitHub, and it will log you in and start a fresh R session so you can follow along. That's the preferred way to do it. There are also instructions on the GitHub page for how to download it onto your computer and start the project and make sure that you have the packages installed. But I really prefer if you do the cloud version. It's a lot easier to do. The one thing that I will say about it is that sometimes it doesn't work the first time, especially if there are a lot of you that just click that link all at once. But I have never had a situation where nobody could get it to work after the second time.
So Dewey, I think your video is frozen again. Maybe just click off your camera for right now.
Click off my camera for right now. Okay, yeah. Thanks. So let's make sure we have this up, and we'll stop sharing the camera. Yep, and so that's better, Brandon?
Yeah, I think so. I think something's going on when you're sharing your screen, but that'll just be a little more consistent.
Yeah, no problem. I'll pop off at some point, and you can have a look, and I'll talk right to you. But we're going to get straight to the goods. So I put this link up on the screen earlier, and if you're watching, you can scroll back to that, or if you're on the Software Underground, the Swan Slack, then you can join the Transform Monday R channel, which is where you can ask questions, or where you can find a link to both this and all the materials on GitHub. So I'm going to hop to this link. And where this will take you is to an RStudio Cloud project. And so it'll take a second to load. But I just wanted to get you guys used to the idea of this. And RStudio Cloud is it's not a familiar tool to a lot of people in geocomputing. I'm essentially opening up a binder notebook. It's basically a Jupyter notebook, but it was just the easiest way for me to deliver this project, and it's a way that I've delivered this material before. But I will hop onto that GitHub page just for a second to make sure that everyone has the opportunity to get set up, because if you can't get this to work, then you will have to install R and RStudio on your computer. And if you know that you're going to be doing this a lot, then I would encourage you to do that. And they're very easy to install. There's no command line things that you have to do to get it to work, which for a lot of you is probably not all that much of a barrier, but for a lot of new people that I teach, and I teach a lot of undergrads, that is often a barrier, so you have to get someone into a command line and type something. Great, so this will take a bit to go, especially if a lot of you clicked on it all at once. But I'm going to have a little bit of a couple of intro slides, and hopefully by the time I'm done that intro slide, that you guys will have this up and running. And if not, then you can hit pause because this is on video. So I'm just going to pop over to the GitHub page so that that address is on the video for you guys. And so the address is github.com, and the repo is paleolimbot, which is me. I'm a paleolimnologist, that's why. And then R for Transform 2021. And this is an RStudio project. And so if you want to, you can click on code and you can download it. And if you have R and RStudio installed, then you can double click on this rproj thing and it will just open right up into the window that you're looking for. It also includes instructions for how to open that RStudio Cloud project. And it also gives you instructions on how to install R for Mac, Windows, and Linux, and how to install RStudio, which will take you to the RStudio page. And you can select your system and it will download the right download for you. Also on this, and just to give you a tiny bit of a tour, this is a presentation that's largely made out of slides that were made by Garrett and Hadley when they were teaching the tidyverse the first time. So it's their original slides are here, Master the Tidyverse, which is an award-winning tutorial. There are also some other learning resources, and in particular, I want to highlight R for Data Science, which is an excellent and free resource that you can point anybody to. And it's also available in other languages. I know it's available for free in Spanish as well. And I know that you can buy translations in French and Portuguese and I believe German. And there might be more on the way that I don't know about or that I can't Google because I don't know how to say R for data science in every language. So with that, again, there are a couple of ways to get to these materials. One is to go to github.com and navigate to paleolimbot, and then R for Transform 2021. And another one is to go to that bit.ly link that I looped on early on, and it will take you to this RStudio Cloud project that should load after at least your second try. So with that, I'm going to get started on the intro. So I'm going to see if I can navigate off of those intro slides. I'm going to navigate into this intro slide. And here we go. So Brandon gave a great intro on sort of the reasons that he has run into R and how R has influenced Python a bit. I'm not going to go into much about why the comparisons between R and Python. For me, I just use them for different things. I write a lot of Django code in Python. There are some really low-level machine learning things that Python is obviously great for. It's the go-to language for that kind of work. There is also a lot of interactive things that I do in R. I do a lot of plotting and data manipulation in R. And there's sort of three main things about R that are the reasons that I switched about 10 years ago. And yeah, I've obviously kept with it since then. But those basically correspond to the three sections that we're going to go over today. So I am Dewey. I'm paleolimbot on Twitter and GitHub, and also on the Swung Slack community. So you can always ping me about R or about anything. I'm a paleolimnologist by trade, and this is a rare opportunity to speak to a crowd that might know a little bit about or might have an idea of what these graphs even mean. So this is a set of cores that I took near Halifax as part of my PhD thesis. And this is a plot that I made in R. And it's one of the reasons that I switched to R in the first place, because prototyping this graph is about 10 lines or less of code. Prototyping is probably 3, actually. And And it's very difficult. You can make this graph in any piece of graphing software in the world. But iterating on this graph is much faster using some of the tools that R has to offer. And in particular, the tool that I'm going to start with, which is ggplot2. Yeah, there's we're going to really start off with the plotting, but I do want to go over a little bit about packages, because in order to load ggplot2, you're going to have to load an R package. And if you haven't run across R packages, you might not know what those are. So R is organized into what is essentially a series of functions or objects. And there's a number of them that are included in base R. And if you load R and you're used to Python, you might be surprised, because I think there's over 1,000 or just close to 1,000 of them that get loaded when you just load base R. So that's both a weird thing, in that you have a high chance of having a function be named something that you meant to be a variable, which is usually not a problem, but sometimes it does cause some weird errors. But it also means that you can do a lot of stuff without loading any packages or loading anything. You don't have to remember what anything is called. There's a lot of things that are really nice like that, like linear models or a t-test. Those are all things that you can do without thinking about what package you have to load. But there's also other packages for R, and R is sort of known for its package ecosystem. And in particular, it's known for the portability of its package ecosystem, in the sense that there are a lot of complaints about how to install various versions of various Python packages. I hear about them. I haven't actually had a lot of problems myself, but people complain about it, I hear. And in R, that is usually not a problem. Most packages that are widely available work on Mac, Windows, and Linux. And most of them are quite well tested. So those are our packages. And to load anything that isn't a base R, you have to install it first, and then you also have to load it to make those functions available. So to install a package, you can do this from within R. It's, in fact, probably the only way to do it, the only easy way to do it. So when you're at your R console, you can type install.packages and then the name of the package. And that refers to the name of the package on the most common package repository, which is commonly known as CRAN, which is the Comprehensive R Archive Network. But people mostly say CRAN, and there's a small contingency of people that say CRAN, or maybe it's a large contingency of people. It's one of those things where if you spend enough time reading the stuff, you develop your own way to say something, and eventually you go to a conference and you realize that you've been saying it all wrong. But I'm pretty sure CRAN is pretty common, but CRAN you might come across. And then to load it, you can type the library function, which is to load that library or package. And that makes those functions available at the console so that you don't have to prefix them with anything. This is something that you're going to probably run across very quickly, and it might be something that you already have run across because somebody told you that there's this R package that does exactly what you want to do, and that is why you are here. It's certainly how I ended up at R. Right, so you can do that once per computer. You don't need to install the package every single time that you run a script. In fact, you really don't want to do that. It takes a lot of time to do. But every time you run a script, every time you restart your session, you're going to have to load that library to make those functions available. And there's a set of packages called the tidyverse. And we're going to start with ggplot2, which is a part of the tidyverse. And the tidyverse does a particularly good job of exploiting the things that make R unique, and that make R something that you might take you less time to do something in R than some other language like JavaScript or Python. So if you go to tidyverse.org, it will give you a bit of an overview of some of the packages, and has an excellent set of help files and an excellent set of tutorials if you click on the Learn tab there. But in particular, you'll probably do a lot of typing of install.packages tidyverse if you are on a new computer. And if every time you're in an R session, you can, if you'd like the access to the packages in the tidyverse, you can say library tidyverse, and it will load up those packages. So that's what we're going to do today. We're going to do library tidyverse. And if you're on the RStudio Cloud project, then I have already installed that for you, so you don't have to worry about it. If you are have downloaded this repo by yourself, then you might have to do this, and I'll go over how you might do that in a second when I flip out. So yeah, there's a little tiny intro bit. So again, this is, so if you haven't gotten there yet, this is the link to that GitHub material that I showed earlier. So it's again, github.com, PaleoLimbot is me, and R for Transform 2021 is where you'll find that material, and it will tell you both how to download that material, open it on your computer, and it will also tell you how to open that RStudio Cloud project. So normally on these your turns, when I do this live, I have this little timer go down. I was telling Brendan earlier, this is a unique format in the sense that it's on video and it's recorded. So I'm not going to wait for 4 minutes because any of you can hit pause if you would like more time. And throughout the presentation, I would encourage you to hit pause and follow these instructions, because the interactivity of this I put a lot of time into, and it is something that will help you get more out of this this tutorial than if you just watch me type. But I will type through all the solutions because you guys might need it or you might get stuck. But in general, when you see these your turn bits, I encourage you to hit pause and do what it tells you to do. So with that, I'm going to hop out of that, and I'm going to hop into what you will get to when you open your RStudio Cloud project, or if you get to the point where you have this open in your own copy of RStudio on your computer. So when it says once per computer, what that means is it's something that you might want to type at this console. And I'm not going to go too much into the difference about the difference here, but in general, this is something akin to a Jupyter notebook. You have places where you have code, and you have places where there's writing. In this case, I've used the writing to type out what your exercise is, and I've used the code, and I've always given you space to type that code. If you're in RStudio, you also have the opportunity to run code at the console. So this is good for one-off stuff, and in particular, when I was talking about installing packages, this is how you would install the tidyverse. Install.packages tidyverse is how you'd do that. And that happens, you don't have to do that every single time you run a script, and you don't really want to do that every time you run a script. But you do want to library those to make those functions available. So I'm going to start fresh because I know that you guys will also be starting fresh. And so to start fresh in RStudio, one thing that you can do is go to Session and restart R. That is something that I'm doing right now so that I'm on the same page as all of you guys. But there's a lot of excellent tutorials about workflow and how to incorporate that into your workflow. So here we are, library tidyverse. If you're coming from Python, this is something along the lines of import all from tidyverse, is how you'd say that. I also have made a package called geoscientists, and that package is a package that contains some geoscience data, because the stock data sets that come with most R packages have nothing to do with geoscience. So I put those two together. So to run one of these, you click the little play button. And there you go. So now it's loaded the tidyverse. It's loaded the geosci data package. And so you should have access to that. I'm just realizing right now that we're in the 0.1 visualize data. And I asked you to start on the 0.0 introduction. So this is a little bit more basic, and it has a little more to makes a little more sense given what I just talked about. So in an R notebook, you can write stuff that is not code. For example, this is not R code, so there's no reason for it to be able to run. You can also write code in chunks, and you can also run that code. So one way to run that code is to hit this little play button. It'll run that, it'll make that plot, And something that I will probably do a lot, if you hit this little run button, it'll run only the selected line and display the output below. So you can run one line at a time. And so it just ran that one line and displayed the output. For me, I've been doing this such a long time, and so I know a lot of the keyboard shortcuts. So you'll see here, it'll give you a shortcut for how to run the selected line. So for me, I'm on a Mac, and so I'm going to hit Command and then Enter, and it will run that selected line. If you're on Windows or Linux, then it will be a Control Enter. So let's do that. So I hit Control Enter, and it ran the selected line. This is something that I do all the time. And it's one of the unique things about running code in our notebook and in general in our studio is that it's very easy to step through things one line at a time. It's something that I don't see a whole lot in other editors, but maybe other editors, I just don't know how to do it yet. So there we are. We've run one chunk. So in general, I've given you a place to write your code in one of these dark gray chunks already. But you'll notice that they're surrounded by these 3 backticks and a very particular jargon of telling you what language. And in case you're wondering, you actually can put Python here if you wanted to execute Python code. But in general, we're going to talk about R today. So all these chunks will be R chunks. So here it's trying to get you to make a chunk. And so it gives you the keyboard shortcut. On Mac, it would be a Command Option I, and it would be Control Alt I on Windows. You can also click this little green button right here, and it'll give you the selection to insert a new R chunk. So I'm going to do it from the menu for now. And now we have somewhere that we can type code. We can print hello. And again, to run it, you can either click this little play button, which will run all the lines that are in that current chunk. For me, I often just hit Command Enter. So again, that was me hitting the Command and then the Enter key, which will get you through that. And if you're confused about what exactly is about to happen, then you can run the selected line right there. And it will run that chunk and display the output below. So if you want to, this is trying to get you to play with that. So you can collapse these chunks if you want to. And in general, you can use this button to run all the chunks before it. So if I assigned a variable in this chunk, and I ran it, then I can also use the value x here. And if I want to run all of the values above to make sure that whatever was in those previous chunks ends up here, then you can run all of them above. And you can access those values that you had assigned above. So another thing about these files, you can hit this little preview button, and it will collate whatever version of of that document that you have right now into an HTML. This is a part of a huge family of packages called the R Markdown family of packages. And there are some really great things you can do. I wrote my entire thesis in something that looks not unlike this, called Bookdown, which is based on R Markdown. And it's a very cool thing. We won't. I'm doing this mostly because I can write your exercise and give you a place to solve it, so you guys don't have to worry about that part. But it's also a very cool thing if you want to continue using it to write your R code. I certainly use it all the time. So we've inserted tidyverse already. So here we need to load it. So the function to load it is library tidyverse. And again, you have to run that code in order for anything to happen. And so now the functions from the tidyverse are available. In particular, there's also the geosci data package, which has all that geoscience data in it. I've already installed that on your server. If you are not using the RStudio Cloud version, then you can, this install.r file has the 2 lines of code that you can run to make that happen. And again, the same rules apply. You can step through this line by line by hitting Control Enter, or you can hit the word run, and it will run more than one of these. But the thing to note is that if you need to install that geoscientist package, then that's a GitHub package that I've made. And so you have to install it in a very particular way. If you're using the RStudio Cloud project, it should already be installed. So I'm going to type library geoscientist. And now the geoscientist package is loaded. So with that, I'm going to hit save and save this introduction. If you'd like to refer back to it to know how to work with these with our Markdown or these R notebooks, then you can feel free to refer to it as you see fit. After this session is over, then I'm going to post the solutions that I typed out in the same repo as when we started, under a folder called solutions. And so if you're chomping at the bit, or if you don't feel like navigating, scrolling back through the video, then you'll be able to find those there. So I'm going to close that. I'm going to pre-open this just to give a preview as to what we're going to be doing. I'm going to minimize this because I'm going to be doing all of the work in this R notebook. I'm going to bring up this visualized data just to give you guys a bit of an introduction to what we're about to do. So I mentioned that what we're going to be doing is visualizing data, and we're going to be using the dplyr package to do it. And the reason we're going to do that is because it is it uses some of the things that make R unique to make complex plots very quickly. And in particular, it's not about making the plot, and there's a lot of, even within R, there's a lot of people that dislike using ggplot2. But for me, I really like using ggplot2 because it's very fast to iterate on graphs. It's really fast to create thousands of them or hundreds of them. And I often do if I'm trying to make the perfect graph. It's very easy to make a lot of them, and it's very easy to change aspects of them. And in particular, it was written in a way that makes it reasonably easy to learn. And a lot of the people that I talk to now that are still using R, that I taught R, they use very little of R necessarily in their current job necessarily, but they do make all of their plots in ggplot2, despite the fact that many of their colleagues are using Excel to do so. So we talked a little bit about this notebook, that setup chunk where we have library, where we load our packages. And in our case, we libraried or loaded the tidyverse, which contains ggplot2, and we loaded the geoscientist package, which has the data that we're going to use as an example. So that rock sample data that we're using is from that Warwick data set. And so I'm going to hop out of here and hop back into our studio. And I'm just going to run that chunk. And again, you can run that chunk using the play button, or you can hit Control-Enter. So I'm going to hit Control-Enter right now, and so it's going to show that. And so much like you would do in a Jupyter notebook, when you run that and you get a data frame at the end of it, it will print out a version of that. And this is our notebook's take on what an HTML thing should look like. A preview of that should look like. You can scroll through the columns. But what I want to get across is that each one of these rows here is a rock sample. So somebody went out and in the field and took that rock sample. And every column here is something about that rock sample. And so I'm going to refer to this as data space when we get down to it. But basically, it's good to know that what each row is a rock sample. You could hold it. You might pass it around in class if you're taking an intro geo class. Again, this is an outcrop, or they picked it up out of glacial float. And I've sorted these into rock types and rock names. And so these are all columns that we're going to be working with, all variables within this data set that we're going to be working with. So hopping back in here, it's your turn. So I know it's a very weird thing, and you're not going to be doing a lot of typing verbatim in this, but this is a pattern that you're going to be using throughout this tutorial, and probably if you continue to use ggplot2, throughout your career, you're going to be typing something along this lines a lot. And so I just want to make you type it the first time to get used to it and to make sure that you have a handle on just how to get started. So again, normally I'd wait for about 2 minutes, and for all these your turns, I would encourage you to hit pause and to take the time to do exactly what it says until you get stuck. And then you can hit play and you can watch me do it, or you can wait for the tutorial to be over today and then navigate to the repo, and it should have the solutions up there for you. So hopping out, let's go to the your turn 1. If you peek ahead, you'll be able to know because this is typed out in some of the slides below. So what I'm asking you to do is to type the code for one ggplot. So what we're going to be doing is we're going to be plotting the Warwick data set. So all of the layers that we're working with are going to refer to this data set. So again, this is a variable that contains that data set. And then we're going to add a layer. And what we're doing is adding a geom point layer. So representing every single row in that data set as a point. But in order for ggplot2 to know where to plot those points, it needs some information. And the information that it needs is the x position of that point and the y position of that point, at the very least. So we have to map something into aesthetic space, which is that x. And we need to choose which variable we want to map to the x coordinate. So these names are all going to be columns in this data frame, and they're all options. You can use numeric or non-numeric columns, and we'll see in a second what that does. But in general, there is some geochemistry about all of these points. So one of them is the potassium concentration in parts per million. So we're going to put that on the x axis. And for the y aesthetic, we're going to map the rubidium concentration. And for those of you who are familiar with the periodic table, those are related elements. They're stacked on top of each other, I believe. And now we're going to run that. And again, we're in our notebook. You can hit that play button, or you can hit Control Enter. And a lot of times, a mistake that people make is they put the plus sign on a second line. And the only way that R knows that there's more coming is if you put one of these infix operators, so one of these plus or minus or times operators at the end of a line. It knows to continue on the next line to look for more. So in Python, you'd stick a backslash there normally, but in R, you don't need to do that. And if we do that, then we get a scatter plot. So I'm going to hop back in here. Yeah, X. So this is what I was going for. And you're going to make a lot of plots, and they all follow this formula. So again, this is what your plot should look like. In general, with these particular elements, I chose them for a reason, because you as a geoscientist might know that when you plot them together, in general, they should be related to each other, just because they're have a similar position on the periodic table. So when you make a ggplot, one thing you're going to be doing every time you make a plot, you're going to initialize that plot with ggplot. Usually you're plotting just one data set. And so you can ggplot that data, the variable that contains that data. Then you have this function that chooses which geometric object is going to be used to display every row in your data. And then you have to tell that geometry how you want to map the columns in your data set, which could be anything, to the information that the actual geometry needs to display. So if you're a point and you have been told that you have to go on a graph, you need the information about where your x and y value is at the very least. The plus always has to go at the end of a line. And if you're old hat at R, You probably already know this, but you'd be surprised how many beginners that is the mistake that they make. So again, I just went through this. We've got the type of the layer, and we use this AES function to map the variables that are in our data set to the information that the geometry needs to draw itself. If you're in Python, you might be distressed to know that there are no quotes around RB ppm or K ppm, despite the fact that they're columns in the data set. That's because R takes a very liberal approach to what can be considered a variable. And in this case, ggplot2 attaches this Warwick data set ahead of everything else in your environment. And so it knows to look in Warwick before trying to pull something out that you might have assigned earlier. In general, you don't have to worry a whole lot about it. If it's a variable in your data frame, then you can use it like you would a variable. You type out a variable normally. So that's our template, and we're going to be going over a couple of this template a couple of times, so that when you get out of here, you can use the cheat sheet that I'll tell you about midway through, and hopefully make a larger variety of graphs using the same recipe. And you can literally make thousands or millions of graphs using this. I think I might be up to thousands at this point. So we'll talk a little bit more about mappings because there's a really good chance that you want to do more than just make a scatter plot. So here's where we started. We had, it looks like I had rubidium on the X here and potassium on the Y. But one of the questions you might want to know is, why are some of these points different than some of those other points? So despite the fact that you know that you have that relationship, you might want to know why some of those points are different. And one of the ways you can do that is to assign different aesthetics to each point besides just the X and the Y position. So you can choose size, you could choose the shape, or you could choose the color. And any one of those things would help differentiate some points from other points, and help you make the plot that you want to make to answer that question. So we're going to try, with our first example, the rock type. So one of the things that you might want to do is to map that to the color aesthetic. So you might want to have different points be different colors based on the type of rock that they happen to be. And so this is, and very specifically, the value of the rock type column. So we have hydrothermal, we've got some intrusive rocks, we've got some sedimentary rocks, and we've got some volcanic rocks. Color is certainly one of them. We talked a little bit about size. We talked about shape. And there are also other aesthetics that you can use for each geometry, which has a slightly different selection. But for a point, the most obvious one is perhaps color or size or shape. And so when you do that, and this is a little bit giving away what your turn will be in a second. But again, we have a variable in our data frame, rock type, and we've got an aesthetic that the geometry needs to draw itself, which is color. So we've got those two things, and if you specify that in ggplot2, then you get this legend for free. Again, this is one of the things that makes iterating on ggplots very fast, is that it takes care of a lot of details in a way that isn't done in some other plotting frameworks. So with this your turn, I've given you that code, and what I would like you to do is experiment with some of those other aesthetics. So again, some of those aesthetics are color, which we just saw. Some of them are size. You can try alpha. You can try shape. And you can also try to use more than one aesthetic. And you can also try more than one column. So I'm going to spend a bit of time experimenting with this because, again, this is a 5-minuter. So normally live, I'd sort of give you guys a bit of time to play around. I'd let you struggle for about 2 minutes, and then I would hop in, give you a couple examples, and then let you struggle a little bit more. But I'd encourage you to hit pause right now and go through that example. Here's where we start with the color equals rock type. So I'm going to hop in to our notebook. And again, what we're starting out with is a plot much like we just made. It looks like I put rubidium on the x-axis and potassium on the y-axis. And so I'm going to continue with that. And the example that I had you starting out with was to add an aesthetic mapping here. So I'm going to map the color aesthetic to the rock type variable. So again, this rock type is a variable in the data frame. I think it's pretty early on. Rock age, rock group, here we go, rock type. And color is one of the aesthetics that the geom point needs to be able to know how to draw itself. And so this is the example plot that we saw earlier. So again, you get this scale for free. You get this guide, the legend for free. And you get different points colored based on the concentration of rubidium or based on rock type, even though they're displayed in space in the same way with the rubidium variable mapped to the x aesthetic and the potassium variable mapped to the y aesthetic. So we're going to experiment a tiny bit. So one of the things you can do is you can change the aesthetic that the rock type variable is named after. So one of the aesthetics you can use is size. It tells you that this is not advised. And that's because it's very hard to differentiate these in this particular case, especially. It's very hard to tell which ones are which based on the size aesthetic. But if you had a different variable, say if you wanted the concentration of lead, that might make a bit more sense. So you can see where some of these high lead concentrations are. If we go back to color, you can also map the color aesthetic. You can map, the lead concentration variable in the data frame to the color aesthetic. So we put color here. Then it will give you a scale. And in this case, it looks like there's some really high concentrations that dampen out that. So if you want to, you can even make expressions based on these things. So if you want to take the square root of lead, or the log of lead, then you can plot that. You can plot that as well. You can treat these things basically just like variables that you would in your regular code. They just happen to live in this Warwick data frame. So let's try the shape aesthetic. So we have the shape aesthetic, and let's try rock type again. And so yeah, there it selects a couple of defaults. So again, we're differentiating how to draw every point based on the value of some column. And let's see, the one that I haven't tried yet looks like the alpha aesthetic. So again, here's the alpha aesthetic. This is the rock type variable, which is a variable in the Warwick dataset. And here it's differentiating, drawing each point differently for each distinct value in that rock type column, because it's a discrete variable. And again, it tells you that this is not advised, and that's because it is hard to tell the difference between these things. There is no natural order. This happens to be alphabetical. So again, maybe it might make more sense to draw alpha based on something like the lead concentration. And that will really make those high lead concentrations stand out. Okay, gonna hop back in here. So we talked a little bit about discrete and continuous. So discrete is a variable like rock type, where you have multiple values that usually they're strings. Usually it's some text. And then you have a continuous variable that is usually some kind of number. And so something like lead. So discrete would be something like a rock type. It's either volcanic or it's either hydrothermal, or continuous would be something like a concentration where it can be anywhere from 0 to some very high concentration. So there's different ways to map those things so that there's a good default way to do it, and also a sort of natural way, whereas if you, with a color, you can have a color ramp. You can represent some value based on some interpolated color from dark to light. Or you can have different hues of color for discrete, so that you see that the human can differentiate what those values are and match them back to the legend. With size, bigger points can represent bigger continuous values or smaller continuous values. And with discrete variables, it doesn't make quite as much sense, but it can be useful occasionally. With shape is usually the other way that you'll want to map a discrete variable, and that will map a different shape for a variable for each distinct value of that discrete variable. So we've talked about the mapping, and this is sort of the trifecta of what we're going with the data and the geom function and the mapping. But the geometry function is big, and there are a lot of them in ggplot2. So these two plots, they're similar in the sense that if you look at that x value and you look at that y label, they have the same data on the y and the x-axis. But they look very different because they're using a different geometry to draw those points. So on the left, we have the scatter plot, where we have each point represented by an x value and a y value. But on the right, we have a smooth, which is a summary of those x and y values through space. So it's the same data, it's the same mapping, but the geometry function is different. Y variable. So again, this is our trifecta that I'm trying to hammer into your heads, probably a little bit obviously, where we have that data, we've got the function that we use to draw that data, and we have the mappings which take the columns in your data and map them into the space that the geometry needs to do its calculation or to do its drawing. So here we are with another your turn. Again, I'd encourage you to hit pause at this point and try to do this yourself. With the one caveat is that I'm going to show you how to get to this cheat sheet that I tell you to use. So basically what we're doing is we're taking this, which is a geom point. We've mapped the rock name variable to the x-axis. We've mapped the potassium concentration to the y-axis. And we have all these points lined up. But what we want to do is we want to make a box plot. So we've talked a lot about how we're starting with a geom point, and maybe you might want to choose a different geom to do that. And that's where we're headed. So I'm going to hop out of here and help you get to that cheat sheet. So where did I? Oh, I brought it up. So the place to start is ggplot2.tidyverse.org. You can also search for ggplot2 package R in Google, and this will be the first thing that comes up. So this is the site for ggplot2. It has an excellent reference section, so you can go through. And in general, what we're doing right now is we're looking at this geometry section. And so basically, you're trying to browse through here and try and find one of these that looks like a box plot. And just as a bit of a hint, it's called geom box plot. I didn't pick a hard one to find. But if it's your first time finding it, it might take a while, and that's totally fine. But I also want to show you about this cheat sheet, which is a visual version of that reference section that is pretty awesome. And so yeah, here's the section on geoms. And so often when you're starting in a graph and you're thinking like, oh, I need to make something, often what you'll do, or what I do, is I browse through this geometry section and pick some of these guys, or pick one or two of them that make sense for what I'm doing, and then try and make my plot based on that. So in general, I think that we're under two variables because we have an x and a y. And we have one of them that's discrete. So we've got that rock type on the x-axis, and we've got that potassium concentration on the y-axis. So that's a discrete x, continuous y. And it looks like box plot is one of the options. So we've got a box plot, and we have an x and a y. And here it's listing all of the aesthetics that you can use to draw that geometry. So when I say use the cheat sheet, this is the cheat sheet that I'm talking about. But also the rest of the ggplot2 website is really fun. And as a little historical note, I am a contributor to the ggplot2 package. I'm down here. And the rest of the people that do it far, far more work. And in particular, Thomas Lynn Peterson, who's the maintainer. There are hundreds of ggplot2 issues, and Klaus Wilk and Hiroki do a lot of it, and Kara and I have contributed over the years. And in particular, Kara has done a lot on the positions. So if you want to jitter and dodge, you can thank her for a lot of that work. So let's hop back into our notebook. Here's where our scatter plot turns up. We're starting with the data set that I had displayed there. So again, we've got data here. This is Warwick. We have our mapping, which is the rock name on the x-axis, rock name, x-axis. We've got our potassium concentration on the y-axis, potassium concentration, y-axis. And something you'll notice that I did here is that I didn't specify the names of the variables. And that's because this order is so common that's the default order for ggplot2. So this will give you the same answer because data is the first argument to ggplot naturally. So if you pull this up, you can see data is the first one, and we'll talk about how to specify global mapping in a bit. But in general, when you're typing a ggplot, you will type ggplot Warwick and geom_point, and then you'll give a mapping, because mapping is always the first argument to these geometry functions. So we just looked up that box plot was the geom that we wanted. So instead of a geom_point, we're changing that to geom box plot. And so if we hit enter there, then we get a box plot. Again, we have the same data, Warwick. We've got the same mapping. We're taking every distinct value in the rock name variable, and we're mapping that to the x-axis. And then we also have the y value. Here's potassium concentration, parts per million. And that's what we want to visualize on the y-axis. And in the middle, we have the geometry, which is able to interpret that and draw something based on that. So that's what I was going for. This started out as a geom_point. But we didn't want a point geometry. We wanted a box plot, geom box plot. And so we changed it into a box plot. So I'm going to hop back into here. Let's see where we're headed with this. So again, we started with a geom_point, and where we ended up was a geom box plot. So headed back to it, we have another situation, but in this time we have a different mapping. So in this case, we're mapping the potassium concentration in parts per million to the x-axis, but what we want to do is make a histogram. And so I'm going to encourage you, if you're watching, to hit pause and try this yourself based on that cheat sheet. So I'm going to leave this up for just a hot second, take a drink, and then we'll have at it. Okay, So let's go back to that cheat sheet and try and find the geometry function that we want to use. So I'm going to go back in. Here's the ggplot2 site. That's the first thing that pops up if you Google ggplot2, our package. Maybe even just ggplot2 would do it. And the cheat sheet is right here. And it's organized in the same way that your brain might be organized when you are trying to figure out which geometry you need. So again, we're trying to figure out what geometry we need. We have one variable, but it's discrete. So let's see what we can find. One, graphical primitives, it's a rectangle, line segments, one variable. What we're looking for is something called histogram. There we go. It's one variable, sorry, it's a variable and it's continuous. And so, yeah, because potassium in concentration is parts per million, so that's a continuous variable. It's a number from 0 to whatever. And so what we need is a geom histogram. So it looks like we have some options. We can have an X, and looks like that's where we have to start. So you notice that you have to type out the whole thing here, and that is on purpose. Because we've gone over some of the things that you can change, and we've gone over how to make the whole thing. But in general, you're going to have to type the stuff out from scratch when you want to make a plot. So ggplot, we have the Warwick dataset. We're going to add a layer, and that layer that we're going to add is, we looked it up on the cheat sheet, geom histogram. So the mapping that we need is, on the x-axis, we want the potassium variable. On the y-axis, there is nothing to map because we're not actually, there's nothing in our data frame that we want to put on the y-axis. A histogram calculates some information that can be put on the y-axis, and it doesn't need any information from the y, and in fact, it would be confusing. And if you were trying to put something on the y-axis, you wouldn't want to use a histogram to draw it. So here we have our potassium variable on the x-axis, and we have the variable that was calculated on the y-axis. So that's what a histogram is it's binning that continuous variable and estimating counts, or calculating counts for each bin, and then displaying that bin. So we've got a bimodal thing here going on where we have a bunch of rocks sitting around, what would that be? 2.5% or 3% or 4% or so potassium. And then we've got another one hovering around probably about 1% potassium. So here we are, we've got, again, ggplot Warwick, we've got our data and our creating of the plot on the first line, and then we're adding a layer. We want a histogram to be drawn. That's how we want to represent that variable. And we're using the potassium variable in parts per million, which is a column in the Warwick dataset. And we're mapping it to that x-aesthetic, which is what geom histogram needs to do its calculation and to display that information. So here we are. This is what we just typed. We've got that ggplot data equals Warwick, or just Warwick because data is the first argument in ggplot, and that will create a plot. But then we need to add a layer. That layer is geom histogram that we want to draw. We want to use a histogram to represent that x variable of potassium in parts per million. So again, parts per million on the x-axis, and on the y-axis, geom histogram will calculate a value and use that automatically. So it may not be the only thing that we use to draw that. For example, a histogram is one way to represent one continuous variable, but you can also use a density plot. So you can use geom density. Again, the data is the same and the mapping is the same, but we're using a different geometry to visually represent that on our plot. So for the next your turn, I'm going to have you make that same plot, but instead we're going to change the mapping to allow for more than one. So again, we've done this above where we just changed the mapping. We did this for a point, but you can also do it for other geometries, and it'll be a very similar process. I'm going to take a drink of water for a second and let you guys get started on this, and then I'll hop in. And again, I'd encourage you to hit pause and type all of this yourself if you're watching this online. Okay. So where we are in this R notebook is right below in the your turn 5. So we're going to start like we did with the histogram, where we type in ggplot to start off to initialize the plot. We're plotting the Warwick data set. We're adding a layer. Oops, I don't have to put equal sign, I have to put plus, add a layer. But instead of drawing a histogram, we're drawing a density, a plot. So the mapping we're going to use is we want the potassium variable on the x-axis. Again, potassium in parts per million. This is the column name in the Warwick dataset. And the x is the aesthetic that geom density needs to draw its, to do its calculation and draw the information on the plot. So if we do this, we end up with this density curve. I think that I asked you to color them by rock type. So earlier what we did with the points is we added another aesthetic to this and added another mapping to this AES function. So instead of just the x-axis being mapped, instead of just the potassium ppm variable being mapped to the x aesthetic, we can also map the rock type column to the color aesthetic. Rock type. So this is much like this, I believe, is the plot that I was going for. And the point that I'm trying to get across here is that mapping of these aesthetics and creating groups based on them works with just about every geometry function. You can almost always put color equals something else when you want to visualize groups. And again, the idea is that, like, why are some of these things different than some of these other things? And so when we looked at that histogram earlier, I told you that it was bimodal. So you have this peak around whatever, 4% potassium, and you've got a whole other group of rocks that has a lot less. And that makes sense if you have a survey of a particular region and you have more than one rock type. So these very low potassium rocks are driven by hydrothermal rocks, and these higher potassium rocks are driven by some of the other types. So for example, primarily these intrusive. So we've got a whole bunch of granite sitting up there. There's a smaller amount of sedimentary rocks, but there are also some in the region. So those are driving some of those lower potassium rocks. And then we've got some of these volcanics, but we've got more than one type of volcanic in the region. There's, I think you'll see in a bit, there's some rhyolite and there's also some basalts, which are totally different kinds of volcanic rocks. So volcanics also have this bimodal distribution. Anyway, some geoscience for you. A lot of you probably know more about that than I do, being a recent quaternary sediments guy myself. Okay, we're almost to the end of this first little bit. Coming up, we have, I'm going to do a tiny bit on how to load data, because that is often the first question that people have after making the first couple of plots. And after that, I'm going to go through some of the data frame manipulations that you can do using the dplyr package. So coming up after these messages, which are more messages about ggplot2. So this is just reiterating what we did earlier with changing that color aesthetic or adding that mapping to our layer. So again, we're adding that mapping where we map the rock tape column in the Warwick dataset to the color aesthetic. And instead of using the geom histogram function to draw it, we're using the geom density function to draw that data. There are other ways to, if you want to group them without changing the color of each one, there are ways to do that. And in general, this group aesthetic is something that you'll run across when you want to change make a whole bunch of segments. And it's a little confusing that I put it in here at this point. However, it's something that you might have to run across that usually that group is calculated for you, but sometimes you need to calculate it yourself. So for our last your turn, for this particular module, yeah, I'm going to ask you to predict what this code will do and then run. So again, if you're watching online, I'd encourage you to pause. This will be right in your notebook and you can run it, see what the result is. Hopping back in here, here's the code that I had typed there. So just like all of our other plots, we had ggplot to initiate the plot. We had the Warwick dataset because that's the dataset that we're working from. This was the first plot that we made where we used the geom point function to draw points with the rubidium concentration mapped to the X aesthetic and the potassium concentration mapped to the Y aesthetic. But we also have another layer, which is this other layer that we looked at earlier. We didn't do an exercise with it, but I showed an example where we have, again, the rubidium concentration mapped to that X-axis, the X aesthetic. And we have that potassium variable mapped to the Y aesthetic. And we're using the geom smooth function to draw it so that we get a smooth line through those things. So I asked you also to run it, so let's do that. So not only did we have one layer, we also had two layers. And it's very common on ggplots to have one or two or many layers. And that is part of the power of it, is that you can combine these things in very cool ways, using the same concepts for each layer. So what we had is the geom point and then the geom smooth. So the geom point is drawn first, and then our smooth is drawn on top of that. And you'll see that it calculates some defaults. It tells you what they are. In this case, it's using a general additive model to draw the smooth. And if you, for example, change the order of these layers, so you had your geom smooth first, and then you had your geom point, then you can imagine that you would have the geom smooth drawn first, and you have the point drawn after that. Sometimes that's what you want, and sometimes that is not what you want. And something that I'm going to go over in the PowerPoint or the slideshow in just a second is that it's very common to have this bit be common between layers. And so because of that, ggplot lets you specify this once and only specify your layers without your mapping. And so essentially what you can do is you can remove your mapping from your layers, and you can add it to your plot definition, where we have on the x-axis, we have rubidium, and on the y-axis, we have potassium. If you're being particularly observant, one of the things you might have noticed is that I didn't actually type X and Y here. And if you're new to programming, that might make a little bit less sense. But if you've programmed a little bit more, if we look at the definition of the AES function, we have X and Y as the first two because they're so commonly specified. And so because of that, ggplot will let you, much like you can use Warwick as the first argument, or you can specify its name. For X and Y, when you're in this AES function, the first two arguments will always be X and Y, unless you name them. But if you wanted to add another, another aesthetic mapping to one of these functions, you certainly can. For example, we can still color every point by rock type, even though our smooth is only being done for one of these layers. You can also smooth. You could theoretically smooth type. And what this would do is it would split it up by rock type and draw each smooth with a different color. Which is very difficult to do because some of these don't have enough samples to actually do that. Oops. But the idea is that you can have multiple layers, and those layers can share a mapping. Yeah, when you draw them and you change the order, then it will change the order that they're drawn on your plot. So our takeaways here, and I'll go over them again in the slideshow in just a second, is that this code template where you start a plot with ggplot, you choose a data frame, you choose a geometry function, and then you choose how to map the variables from that data to what that geometry function needs to be drawn or calculated. And that is a pattern that you can use to make a whole lot of plots. I put some links down here very much on purpose because there are some really, really great resources for how to use ggplot2. It's been around for a long time. These are only a couple of them, but there's data visualization chapter in the R for Data Science book. The R for Data Science book has a couple of chapters. I think there's or at least two or three chapters on data visualization. I put the data visualization primers, which if you're using RStudio Cloud, there you can sign in, and there are a number of data visualization tutorials that are interactive. But the only downside is that they don't use data about rocks, which you guys know and love. So I'm going to take a brief break here, probably just only about 30 seconds or a minute. Just before we start in on the next module, it's 3:15. This tutorial runs until 4. So basically what we have left is we have here our basics. And you hear there's a whole whack of stuff in this transform data slide tutorial. And what I'm going to do is I'm going to put up the slides for all of these after the tutorial. And you guys will be able to hopefully maybe perhaps get through more of this transform data tutorial than I have time to go over here. And maybe some of you are done it already because you're going faster than I am. So yeah, I'm going to hop off here. I'm going to close this cheat sheet. And I'm going to just stick up the next keynote slide. Just for a second. So I'll be back in about 30 seconds, I would say. Okay, here we are. I'm jumping back into it. So I mentioned that we've got a couple more modules, and in general, this is a very short one about importing data, and it's often the first question that I get after people have learned about ggplot2. They're like, okay, but like this is one thing, but how can I like assign variables and import data? And particularly if you're coming in from Python, it's a bit some of this is a bit different. So I just wanted to go over a little bit about how to do that, which might help you get started in some of the stuff that you want to do in R with some of your data. So I'm going to hop in there in a second, and let's open that second tutorial. So I'm going to close this. I've saved it, and open up this second tutorial. So just like the first tutorial, we have a setup chunk that has loaded our packages. We'll have to run that. And that will make sure that these functions are available, and in particular the couple of read functions that I'm going to use from the tidyverse that we'll be using. Okay. So let's hop in here. One of the first things that I get asked, especially from geoscience, and again, I was teaching this originally to geochemists, and I started out in something closer to geochemistry, where we got huge Excel sheets back from the lab, and that's kind of what we're using to to load these things. So there is a package to do that, and so if you're using the RStudio Cloud project, then this package has already been installed for you, and if you're using this on your computer, then you'll have to install the package using install.packages, and I'll go over that in just a second about how I would go about doing that in my local R session. So again, we're loading a package called readXL, and there's a function called read_XL, as you might imagine, and that reads Excel files. So I've included in the GitHub repository and in the cloud project a file called warwick.xlsx, and that is a file that you can read using that function, and it will give you a data frame very similar, if not identical, to the Warwick dataset that I have already provided you. There's a couple of arguments that are needed, or that are helpful if you want to customize exactly what gets read. One of them is the sheet. The first sheet is read by default, and the second one is the range, which might be useful if it's not the column names aren't in your first row. So you might want to read just a very particular range of data. I mean, you can specify this like you would in an Excel formula with that little colon-y guy to specify, to specify sort of top left and bottom right cell that you meant. Yeah, and so in the your turn, I've included a picture of this so you don't have to open this if you don't want to. But basically, we have this this Excel sheet. This is sheet 1. I've given you the name of the file. I've given you the name of the sheet. But you can, I was hoping you'd do is experiment with the range parameter to see how that works and how you can read in data from different parts of your sheet. Okay, I'm just leaving that up there long enough so that you could pause it if you wanted to. I'm gonna hop out of there and come in here. So one of the things that we have to do is we have to load the readXL package, because without it, we don't have access to this readXL function. And so I started out without a range. And so if we, the sheet is actually set up in such a way that all the column names are in the first row. There's no excess information anywhere, and so you can just read the Excel file, and because it's the first sheet, There's no extra information on top. It'll just work. But sometimes you will need to read in a sheet that is not the default sheet. In this case, the data is in sheet 1. And again, sometimes you're going to have to read in data from somewhere that's not from a sheet that doesn't have just all the column names on the first row, and no extra information anywhere so that read Excel doesn't get confused. And there you can specify the range. And here we're going to start at A1. And I think I had a picture of the sheet here. So let's go over to G6 and see where we get. So that read 6 rows, which was the first row was all the names. The next couple of rows were the 5 rows of data, and it only read over to the G column, so A, B, C, D, E, F, G, so the first 7 columns. 1, 2, 3, 4, 5, 6, 7. So we got 7 columns. So that's the gist of how, the very beginning of how you start to read your own data in. Once you start reading your own data in, you'll probably find that your data has mistakes. And fixing the mistakes in your data is a much larger topic, which is why I never teach that first. Because people tend to get hung up on that. They can't fix the data, fix those without knowing a whole lot of other functions. And it can be a very slow process. Something that I wanted to go over here was that I assigned this to a variable. So in R, you can use the equal sign if you want to. Personally, I always use this arrow thing. It looks a little bit weird when I first switched from Python over to R. Really what it helps me do these days is that when I'm switching between Python and R, it helps remind me that I'm typing R code. I've never really minded that arrow thing. It helps keep these variable assignments different from specifying a function argument. But if you really, really don't have, there's lots of people that do have very strong opinions about this, you can keep using that equals sign if you want. I'm not going to for the rest of this presentation, or usually in any code that I have any control over whatsoever. And again, something that you can use when you're doing this R notebook, this assignment won't actually print out anything, which is good because usually when you do this kind of thing in an R chunk, you don't actually want it to print anything. You want it to do its assignment. And if you want to look at it, you can type that variable name. And so that's what I did here. I did that assignment. And if you type that variable name and hit Control Enter, which I'm doing, or again, you can hit that run guy, and it'll run everything. Because you have this variable name bare, it'll print out the value of that just by sticking its name at the bottom of that chunk. And I actually forget if that's how it works in Jupyter Notebook. Something else that I wanted to go over, something that actually happens to a lot of people when they're doing these chunks, and perhaps you've run across it very early on and never didn't have the chance to ask me because this is not in person. But a lot of times people do something like this. They hit backspace by accident and they get a lot of weird red things. This is just a text file. And so this is, again, just text. And you can screw up how these chunks are defined, which it really has to be very specific in terms of these 3 backticks starting without any white space onto the left. And so sometimes you can do this, and often people do when they're just navigating around and hitting backspace or copy and pasting. And the solution is to get that on its own line. Or if you have screwed it up and you really have no idea how to fix it, you can. Oops, I got a little confused there too. You can type in a new R chunk with those 3 backticks and R in brackets, and then you can copy the code that you wanted into the chunk that you know works, and then you can delete this chunk that you didn't know how you messed it up. But again, yeah, these are just text files, which actually makes it pretty great to use these things in version control. remember when I was tuned into the version control tutorial earlier, the workshop earlier, he was using a tool to use Jupyter notebooks in Git. And the tool works really well, but this just sort of never needs that tool because it's just a text file. So you get the diffs lining up pretty well if you're into that kind of thing, which you don't have to be. So certainly an Excel file is one of the ways that you might have data. Another very common way to get data in is a comma separated value file, or a CSV. So I've also included a Warwick CSV variable. And I'm just going to pop up that your turn because I think I have another one defined here. And so we've used the read Excel function to read that, that file. But there's also a .csv version of that. There's warwick.csv. And so what I'd like to do is just type in what you think, based on that read Excel code you see above, what reading in a CSV of warwick.csv might look like. Okay, hopping back out. Let's make that work. So I told you what to call the variable so that you didn't have to make up a name. Making up a name takes a lot of brain work. Warwick CSV. I'm going to use this little arrow guy to, which I usually read as gets. So here I read this as Warwick Excel gets read underscore Excel warwick.xlsx. But we can also use the read CSV function. And the file that we're going to read is warwick.csv. So how I got this little menu here is that I hit the tab key. So you can also hit it before that. If you have a set of quotes up, then RStudio will try and find a file that matches what you've already typed. So warwick.csv. And if we hit enter, you'll see that it spit out a lot of information, and I'll go over what that actually means in a second. But just as above, because we assigned it to a variable, it won't print out. But if we just type the name, then it will. So here we can see that the values of the two of these guys are the same. Here we're only reading the first 5 rows because of the range that we chose. But here, we're reading the whole CSV file, so we have the same information, but all of it in this case. So when it read this, and if you use the read underscore CSV function, it will always spit this out to you. And they might actually change this default in the future, but in general, I really like this output when you first read it because it tells you the assumptions that it made about your column types. And so often, if I'm I usually keep this output somehow. So often when you first run the script, it'll spit this out, and sometimes it will help you catch errors. You can also specify this if you want, but that's outside the scope of what I'm trying to get you guys to learn today. I just want you to know how to get your data in if you want to start plotting your own data. Okay, there are also more of these functions. There's read TSV might help you out, but in general, data import is something that R has been very good at and is very fast at. So there are often very fast ways to get huge amounts of data in particular, if you're using Apache Arrow or anything, which you might be using because Pandas has a very good integration with it. You can read Parquet files and all sorts of things. R is a data science language, and so getting data in and out is something that it's really good at. Another thing that I wanted to mention is that it's also very good at getting spatial data in and out. So if you have shape files, it can read them just like a CSV, but the function for that is read underscore SF. It's outside the scope of what I'm going over today, but I'm a huge spatial nerd, and that's in most of my life. That's what I'm programming in R, and so I wanted to mention that it exists. So there's some chapters on this as well in R for Data Science. So the workflow basics. This will go over like variable assignment and and the ways to create vectors and why everything is a vector. There's some things around that are helpful to know once you've decided that you want to continue in R. There's a chapter on data import. It's a fairly long chapter because data import is actually really hard. And so it goes over lots of different ways that you can do that. And there's also a set of tutorials on programming basics in RStudio Cloud Primers, which are a set of interactive tutorials that are very well done. So I'd encourage you to read all of these or read some of them, whatever speaks to you, if you'd like to continue learning about some of this stuff. So I'm going to hit save to save my changes. Close out this. See if I had any wise words of wisdom for you guys. And here, it looks like I didn't have any wise words of wisdom for you guys left in that slideshow. And with that, I'm going to pop into this transform data slideshow. See if we can get to the top there. I'm going to hit play on this to show it up my screen, and I'm just going to take a hot second to grab a sip of water, and I'll be back with you guys in a second with the last little bit of this tutorial. Okay. This is a tutorial that is actually quite long, and so I'm not going to go through all of it, but I wanted to leave the tutorial up, or I wanted to leave all the slides in because it might be something that you are interested in keeping going with after I'm done talking. In general, the two things that I come back to R for over and over again are this basic data manipulation, this data transformation, and the plotting are the two things that that really are the reason that if I'm choosing to open up a notebook or whether I'm choosing to open up RStudio, it's the reason that I open up RStudio. So I'm going to take a bit of a break from geoscience data to go with this baby names data set, which is it's contained within a package, but it's just a data frame called baby names. And what it is it's the Social Security Administration's collection of what the popularity of various names for every year. And so this is just how they catalog it with the year, the male or female, because that's just how they cataloged it at the time. And then we have the name and how many and the proportion of which is a derivative of that for every year. So we're going to be exploring this a little bit. I think it's a little bit of a fun data set, and I discovered that my name became very popular in 1880 as a result of playing with this data set, which is because of, I believe that there was an Admiral Dewey that hit the news around then. I've been told by my, after I told the story to my mom, she told me that I was named after a relative that predates that. So I was Dewey before it was cool to be Dewey, apparently. The person who made the slide originally was named Garrett, also the population of Garrett. I think he was named Garrett a little bit before it was cool to be Garrett, also. Not to give away his age. In general, it's a huge amount of data, and we're not going to spend a lot of time plotting this, but we are going to spend a lot of time trying to figure out how to get this huge amount of data into this tiny amount of data, because that huge amount of data is not like when you are just faced with a wall of data. You just read in your giant log file, and you have all this information, a table with a ton of rows. And so you need to figure out how to get the rows that you want out of that. And that's where dplyr has a lot of functions to help you out. So just like the ggplot2 was a grammar of graphics, so it was a grammar of how to create plots, dplyr is a grammar of transforming tables. It draws a lot from SQL. And so if you already know SQL, you'll recognize a lot of the ideas. And actually, dplyr code can be translated into SQL, and often is, to query a backend like Postgres or something else, if that's something that means something to you. So you can extract variables with the select function. You can extract cases, so rows, with the filter function. And then you can reorder those with the arrange function. The first one we're going to go over is select. So you might start off with a data frame that has a lot of variables, but you only need to look at a couple of them. So the first argument is the data frame that you want to work with. And then after that, you can name columns, or you can also use helper functions to help you select more than one column based on a pattern. So for example, with our baby names dataset, you might want to select just the two columns, just name and proportion, because if maybe the analysis that you are doing doesn't care about what year it happened in, or the sex, or the number of the actual number of names that it's referring to. So that's we'll hop into the notebook. Okay, so I closed the last one, and where we are is we did this number 1, visualize data. We did this number 2, our basics, and now we're going to hop into this number 3, transform data notebook. I'm going to minimize this guy because I'm going to execute all of my code in the notebook. And we're going to start here with loading our packages. In its case, the tidyverse, which contains dplyr, and we'll load dplyr when you say library tidyverse. But also we're going to load the baby names package, which has this baby names dataset contained within it. So again, I'm going to display guy to run both of these lines at a time. If you have been doing this all along, there's also you can run one line at a time, either from this run button up here. Although I don't often click this anymore because there's a shortcut which is Command Enter on a Mac, or Control Enter if you're on Linux or Windows, which can help you run one line at a time. In this case, I'm just going to run all the lines, and it will load those packages for me. If you're doing this on the RStudio Cloud project, then you will notice that these packages have already been installed. If you are doing this on your home computer, you might have not installed, in particular, the baby names package yet. And so to do that, I'm going to do it in this console down here because I don't want to run it every time I run my analysis, which might be contained in this notebook. But I'm going to type in install.packages. And then I would install the baby names package. And I can actually, I'll do it now just in case I might have a, again, I'm just to start off on a fresh page to show you guys how this works. I'm going to restart my R session to clean up my global environment. I'd already loaded the baby names package, and I'd already, so it gave me an error when I tried to install it because it was already using it, and it was like, hey, I need that. Don't replace it with a newer version. But if you wanted to, you can type in install that packages. And so what I just did there is I hit the up key. to do the last line. This is something you can do in the Python console too, or in Bash, if you're familiar with Bash. You can do that. So I'm going to install the baby names package, and what it'll do is it'll download from CRAN. You see that I talked about CRAN earlier, and it will install it. And so now you can load it. So if you were doing this on your home computer, you might have gotten an error there that said there is no package baby names. And whenever you get that message, and you might get it a fair amount, I find that beginners tend to, when they're just setting up their R package session and they haven't installed much yet, that's an error that comes up frequently, is there is no package called. And it's not a very good error message because there is a package, you just haven't installed it yet. And so that's how that works. And that's an example of using the console to write one-off code that you don't want to run in your analysis, but that you do need to run to get your analysis set up. So frequently that is install.packages. So I restarted my session, so I have to make sure that those packages are loaded. I'm going to run this session to grab our preview of the baby names dataset. It's really big, if you haven't noticed. It's almost 2 million rows and then 5 columns. And so where we were in the your turn was selecting more than one column. So here's where we started out. This is the name of our data frame, baby names. And these are the names of the columns that we want to select. And this is very similar to the ggplot2 code, where we're referring to variables, whether they're in the data frame or whether they're in something we assigned in our environment, that you can refer to names in a data frame without the quotes around them, almost everywhere in the tidyverse. So if we run this code, then we end up with something that has the same number of rows, but we've selected selected columns. So just those bare variable names. So to only select the n column, you would have omitted the prop from that previous code, and it omitted the name, and you would have selected just the letter n. So there are helpers to do this. So one of them is the colon to select a range. So if you wanted to select the variable starting at one, a variable name, and ending at another, then you can use the colon to do that. You can use the minus to select not a column. And there are a number of helpers that you can use to select columns that match a particular pattern. So one of those patterns is something that starts with something. And I'll give you a list of those in a second. But there are also, you might want to select all of the variables that end with a particular, in this case, it's just doing one letter, but often it's a pattern. Often I'm doing this kind of thing for, I have a bunch of columns that end in standard deviation, so SD. And usually I want to select all of them or not select them. And I'll go over in a second how to use these. So there's a lot of them that you can use within the select function. One of them is contains. You can use matches if you know what a regular expression is and you want to use it. And you can, if you want to, you can refer to these things with quotes around them, which you might do because you have those stored as a variable somewhere else. Okay. So this is in a place in the cheat sheet, and I'll go over where to find that cheat sheet just because we're on that slide. So just like earlier, I'm just going to grab a new window real quick. So just like earlier, we were on ggplot2.tidyverse.org. You can also go to dplyr.tidyverse.org, or you can Google dplyr package, and it will take you to this page, which is a very similar looking web page that has the cheat sheet. It also has an excellent reference section, which tells you how to do that, and also has a number of articles, and it has a tutorial on how to get started, and a list of the common functions that you might use. So again, this was on that cheat sheet, which you can find at dplyr.tidyverse.org, or you can search dplyr package, and it will get you there. And now we'll hop into a quiz, which is a fancy word for another one of those your turn guys, where there's some code. But you can experiment with this, and I will in a second in the notebook. That there are a couple of ways that you could possibly select the name in the end column. And this is to get you practice using some of those helpers, which are really useful for selecting more than one column or not selecting more than one column at a time. Right. So this is a good example of time that you might want to run not all of these at once, but run them one at a time. And I'll show you what happens if you run them all at once. If you run them all at once, you get all 4 outputs, but it doesn't really tell you which one came from which. I mean, they're in order, but you might have some lines in here that didn't have some output, and that might be confusing. So it might be actually a bit easier just to step through these one at a time. So again, I'm going to use this command enter shortcut. You can also say if you're on Windows, you'll need Control Enter, and if you're on Linux, you can use Control Enter as well. So let's see, this did it. So this is because the baby names data. I'm going to use another trick here. I'm going to put Command Enter again, but if you have text selected on a given line, then you can only run that. So if I hit Command Enter here, then you can get only the selected text to run, which is useful in this context because what I'm trying to do is look at this original and then look at the result and see how it changed. So in the original data, we had year, sex, name, n, and prop, but we're unselecting the combination of year, sex, and prop. Year, sex, oh. So then we're left with only name and n. So it looks like that is one of the ways that you can select these 2 columns together. So predicting what this will do, if we look at our original baby names data set, we can select the range from name to end. It looks like that's going to start here and end here, so it's only going to select those 2 columns. So if we run that, it's going to select those 2 together. If we select only the columns that starts with n, we're also going to get that because if we look at our original data, there aren't any other columns that start with the letter n. But if you look at them that end with n, we only have the n column. And so that is the answer to this, where it's just that last one, where it's the only way to do that. There are, again, all of those other selectors, selector helpers work here, and you can also use them together. So you can say starts with n or contains ye, and that should also get you the year column. And you can add a string any number of these things together that you want. And maybe a good thing to put here is that you can also specify by number. So if you want the first column, it should it will give you that as well. Okay. We're almost, we have about 10 minutes left. And I'm just going to scroll down here. There's one part that I really want to get to. Okay, we're going to go over the filter because it's a common one. And then I'm going to tell you how to string these things together. And then I'll put these slides up on the GitHub, and everyone can be on their merry way. So we went through this. all of these things are ways to select only those two columns. And so as you can imagine, one of the things that you want to do is select different columns, but you also might want to select subset by row is a very common operation. And so just like the select function, the first argument is the data frame that you want to transform. And then you have any number of logical tests that you might want to execute. So basically, any time that the test is true, you want to keep that row. So it's very common to most of the dplyr functions. You've got the function, first argument, all of that data frame. And then you usually have a ... where you can, usually you're operating on columns or picking columns to operate on. So let's start out with the filter function, get a little bit more into it. Here again, filter is selecting rows, whereas select was selecting columns. So again, we have a lot of rows in our table, and we're trying to remove the rows that we don't care about and filter only the rows that we do care about. And just noting here that here we're testing for equality and that we're not setting a variable, but filter will warn you about that if you only type in one equal sign as opposed to two. Just like Python, you need two equal signs to try to test for equality. So equality is one of the things that you might want to test for. In R, these are a lot of other common ones: less than, greater than, equal to, combinations of those, not equal to, and I'll show you in a bit group membership. It's very similar to the Python, which also uses in, but here you've got a couple of percent signs to worry about. So these are common functions that you're going to use within filter because they are going to test columns, test the columns in your data for some condition, and anytime that condition is true, then you're going to keep that row. So popping back in. This is an exercise where we're going to try to get a whole bunch of things based on a couple of filter operations. So you're going to need 3 different filter operations to solve this. So all the names where the proportion variable is greater than or equal to this number, 0.08. We're going to try and get the rows that are all the children that are named C. And then we're going to try and get all the names that have a missing value for n. And this is going to tell you that it's going to return an empty data set. And it's also going to introduce you to the is.na function. It's exciting. So I'm going to hop out here. And here we are. So let's do all the children's where the prop is proportion column is greater than 10 or equal to 8. So we have the filter function. We have the data frame we want to operate on, data names, and then we have conditions that we want to test for. So the prop column is what we're going for here. So prop greater than or equal to. And then the threshold we want is 0.08. If we run that code, again, I'm using Command Enter here. Then here it looks like at any given year, it looks like 8% is incredibly high. And the only names that have ever achieved that were John and William in the 1880s. So pretty early on. Most looks like the proportion has been lower than 8% for a lot of most of history for most names. Okay, let's do the second one. The children named C. So that's telling you here that you need the name column. The name column. We want equals because we're selecting the rows where we want this column and we're looking for the value. SEA. So it looks like it's a reasonably unpopular name that mostly happened during the 80s and 90s, as did many mistakes. And then for the missing value, I showed that on one of the slides, and it's one of the things that is unique to R in the sense that they're built in, is a missing value is characterized by NA. So you can test for that using the is.na function. And the column we're interested in is that n column. And it gave you the hint on the slides there that this should return an empty data set. And that empty data set will show up here as a table with 0 rows. So that is this particular argument, or that's this particular exercise. What I'm going to do right now is, there pretty much is, there's very little wrap up, but one thing that I wanted to get to was the pipe. And this is something that's actually going to be built into R pretty soon. But this is how most people, many people, are stringing together dplyr operations, because often when you're filtering and selecting and arranging and grouping by and summarizing, you want to do more than one of those at a time, because every time you rename a variable, it's more mental work that you have to do, and often you can avoid that, and it often is much faster to avoid that. Or you end up with a name that means nothing, and that is also hard to read. So you can eliminate that by stringing these things together. One of the things that you could do to string them together is to nest those functions, but that leads to code that has those names in the reverse order. So you have arrange, select, filter, but really what you're doing is you're filtering first, and then you're selecting, and then you're arranging. So to get around that, you can use the pipe operator. And so what it's doing is it's putting that variable in the first argument of whatever function you're piping into. And as a result is you can change code that looks like nested function calls into a linear operation. And so in this case, we can change that above code into something that looks like that pipe line below, where you've got baby names, then filter, then select, then arrange. So this is the example that they use here is little bunny foo-foo. You hop through the forest, you scoop up the field mouse, and you bop it on the head. Whereas before you would have had to type a total mess of stuff to get that code to work, and you would have had to make up a lot of names. Every time you have to make up a name, it takes time. And it's hard to read. I use this now constantly ever since I learned it. You can type that with Command-Shift-M on a Mac and Control-Shift-M on Windows. I'm just going to briefly hit up. This was the Your Turn 6, where we take baby names. That's the pipe. You can type it in one at a time. A %sign, a right-hand arrow, and then a %sign, or Command-Shift-M on a Mac, or Control-Shift-M if you're on Windows or Linux. We're going to filter it to sex equals F. Born in 2015, year equals 2015. Then, again, I'm typing that Command-Shift-M or Control-Shift-M. You can hit, we're doing select. So we're going to select the name in the N column, name, N. And then I skipped the arrange section. So the most popular names are near the top. Let's actually just see what happens if we do this. So this gives us the name in the end. So if we want to arrange, if we want the most popular at the top, then we want the high numbers of n to be first. So that's ordering by n column descending. There we go. In 2015, the most popular girl's name with Emma, Olivia, Sophia. And that definitely rings true with some of the names that are in our daycare or in our daycare and kindergarten around here. Okay, so I don't have a lot of wrapping up to do other than perhaps I'll put that title slide up, and yeah, something that maybe I'll wrap up mostly by heading over to that GitHub repository, so github.com/paleolimbot, which is me, and then R4 transform 2021. That's where you're at. Because this is your key to both the exercises that we did today. I'll post the solutions to these exercises shortly after the presentation. And it also gives you a list of resources for, again, installing R if you have decided that this is something that you might want to do. And for learning more stuff in R. I really should collect some of the other language links for R for Data Science. I have them somewhere else, but I didn't put them on this repo. In particular, it's available for free in Spanish. I know for sure, and if you can always try and hit me up on the R Swung Slack channel and to find it. RStudio Cloud Primers are great. These are the things that I always point people to. These are put together by the RStudio education team, as were many of the slides that I just showed. And there is the Master the Tidyverse GitHub repo, which has a number of other resources if you're interested in teaching something similar to this in the future. So yeah, thank you guys so much. And yeah, I look forward to answering any of your questions on Swung in the future. I'm not a very active member on Swung, but I look forward to becoming more active as perhaps more people start using R, or more people start having questions about R. So I'm going to turn it over to Brendan if Brendan's around, and I'm just going to start throwing my title slide and start getting ready to wrap up.
Great, Dewey. Thank you so much for that. That was really interesting and a good overview of R.
Yeah, you're welcome. It was a pleasure to be here.
Very good. Well, everyone, thank you for attending this tutorial today. Again, we want to thank our Transform 2021 sponsors. We had Studio X, AWS, and of course our friends at Agile. So we thank you for tuning in, and yeah, still lots of great stuff going on this week at Transform 2021. So again, thanks for tuning in.